Okay. All right, folks. This meeting is now being recorded, and by continuing to be in this meeting, you are consenting to be recorded. Okay. Good evening, and welcome to you both, Chase and Geeta and Yelena as well, and to everyone watching. Welcome to our Module 3 webinar, and we'll go over the next to the etiquettes, but I think with a short class here, I'm going to skip that. We don't need to follow that. I think Chase and Geeta, you have the floor. You can just interrupt me anytime and ask any questions at any point in time. Come up on the video, absolutely no issues. So we can it's a nice setup here, so we can utilize that. It's okay. So today's agenda will go over the big data processing. Then we'll talk about assignment 3, and then we'll talk about any questions that you may have in mind for anything in general about module 3 or about the course as well. Okay. So first things first, before we talk about big data processing, right? Just a quick retrospective on weeks 4 and 5. So, you folks, it did an excellent job. So Geeta, Chase, and your peers, your classmates have done a wonderful job. But I would still love to get your feedback on this assignment, if there is any. I would want to know, if it was really difficult, or you found it confusing, or the instructions were not right, or if you just enjoyed it. So, any thoughts or comments that you guys would like to share? Anything on your mind?
I can go first. So, personally, for me, I thought the instructions were pretty straightforward. Your video on how to navigate through the AWS classroom was also very helpful. And if you follow, if you follow everything that you gave in order, the assignment's pretty easy.
Right. Yeah, but yeah, thank you for that feedback, Geeta. And yes, the assignment is easy. And yeah, with instructions, it becomes easy. As you said, if you follow it perfectly, everything works okay. But I'll tell you what you have, or what you're developing in the lab is very powerful, is something that you will see in the enterprise world. Of course, with the scale a little bit bigger, higher, but the concept is same. So if you felt that what you did was simple, easy, that's how a lot of these technologies are. It has made things simple and easy for folks. If they understand the concept well, you'll have to just scale it, and make use of these technologies for bigger problems. That's pretty much it. But yeah, what you've developed is, and you see that we'll talk about it in this webinar as well as in the next webinar as well. But it will start becoming clear that what you're developing is very powerful. Okay, so thank you for that feedback. Chase, do you have any for us?
No, I'm actually still working on it. So
Okay.
I'm sorry I'm behind a little bit on the deliverables for the course, but I'm just wanting to.
No worries. I understand.
Yeah.
Completely understand. But yeah, whenever you have any feedback, maybe let us know for the previous or any assignments here. Okay.
Okay. Awesome. Thank you.
So yeah, I once again, the discussion postings pretty good. I think this class is pretty thorough, but once again, I think you can still have a little more depth and variety on what you pick and choose for your discussion topics. But once again, don't get me wrong. I'm not saying I'm going over this last discussion posting. I may not have interacted with you as much as I did with the previous discussions, because I got little as I said, I got little defocused and I had to kind of put my focus in. I got distracted with the assignment 3 change that I had to make. So I kind of got a little distracted with that, and I couldn't spend time with the discussion posting. Having said that, well, I was still able to read your postings, so they were pretty good. I liked the some of you have kind of really gone on to read and do a lot of research before submitting that. But once again, take advantage of the fact that some of you do this earlier in the week. So maybe you could add a little more, make it a little more, meat and depth into the submission postings. Plus, engage with your classmates as much as you can. It doesn't have to be just two classmates, maybe engage with more if you'd like, right? Because this is where a lot of your in education is coming from. Honestly, it's by engaging with your classmates, knowing what they are thinking and knowing what they think about your ideas, about your posting. And I think that kind of just starts a process of learning that it's even beyond the reading and the lab sometimes that you do. Trust me, that's how I've done a lot of my learning has come from knowing a lot from my classmates. So, okay. So once again, I will always encourage you for that. And the next discussion topic is really interesting. So I'm really looking forward to that. And I hope I do not get distracted with anything else that could be going around, and I can interact and engage with you all, because it's going to be an interesting one. So very soon you'll know that. Okay. And as I always say, take advantage of these webinars. This is I'm just providing and trying to give you this opportunity to come in live and have this live session and live chat with me. And this is also a place you can come up with your own agenda as well. Trust me, I do not want to impose the agenda here. The only reason I come up with something, an agenda here to talk with you, of course, I would try to come up with something that is supplemental to what you would have done. And secondly, or you would have learned during the module. And secondly, to make sure that, yeah, our time is going to be well spent here. And I respect your, that you would be coming up here, for these sessions. But having said that, please, if there's any agenda on your mind, you can let me know ahead of time, or you can let me know impromptu as well, because this is all about having this interaction, making this a two-way street. Please do not think this is going to be my meeting, my webinar, and I'm going to be coming up with things that I need to finish it off on time here. Okay, far from that. Sorry about that, guys. I don't know. I did not cough all day. I did not cough all evening, all week. I don't know, all of a sudden it got choked up a little bit. So I apologize. Okay. All right. So yeah, please take advantage of these webinars. And I think we just have one more left in this course. So you would want to kind of also be there and take advantage of that fact that we will be meeting for one last time 2 weeks from now. Okay. All right. So what have we, where are we in our journey? So you learned about big data ingestion, right? You learned how to, have files, you can take your files and load it into S3 or maybe into any databases. You've done some of that also in the past, and you do it on a day-to-day basis. Maybe some of you already worked with other databases in the past, but as simple as loading a data set or a data file is something that you would have done in other classes as well. And you would be doing on a personal basis as well. Maybe some of you are much into Microsoft Access, or maybe just just use a simple MySQL at any databases in the past. But once again, it's about learning how to take a file, a CSV file or an Excel file or maybe other data sources, and load it into the database. So you kind of have learned about that, right? You've gone through that a bit. You also learned about in the previous module about once you ingest the data, pull the data in, you would want to store the data. How would you store large amount of data, right? You learned about all storage technologies that are out there, right? All the storage tools that are out there. So we did that in the previous module. And in the current module, where we are talking about big data processing, right? After you pull the data in, you've stored the data, how are you going to process the data? And that's what you're going through with module 3. And then next we'll go on to the next time is to complete this circle, right? Or to complete this cycle here is or to complete the different phases of data analytics here, or big data analytics, which is getting into after you have pulled in the data, stored the data, process the data, how would you derive insights from that data? How would you do any kind of machine learning or predictions that you would want to do, or even and even view some of the, and as I said, some of the insights that you want, the dashboards that you want to build on the top of that, right? So all that all this is going to culminate into doing that, which is going to be your final module and the final phase, and which includes also some of the data that comes in as very fast and furious, the streaming kind of data, right? So that's what we will kind of learn in the next module, right? But right now we are in the third phase here, which is big data processing. So now that you've kind of gone on to learning about different big data processing and technologies, the frameworks. So let's validate these statements, right? So my first statement here, and I would want to know your thoughts about each of these statements, what you think about it, either they're true or false, or any kind of comment here, right? Because this is important. Um, Once you have gone through and learned all that you've learned during this module, and I'm not kind of making these statements up. Honestly, yes, in a way, technically, yes, I put that in, but this is something that you would be confronted with, right? Or you will hear from someone, or you'll be questioned by someone. And you as a data scientist would have to really understand it well and address people's concerns or questions. Or if somebody's making a loose statement, right, you'll have to correct them, saying, "Hey, this is what it is." So I know I could bring in a bunch of statements here, but let's for the sake of, in interest of time, we'll just go through a couple or two or three of them here. Okay. So the first one here, using the storage management tools to query and analyze the data is good enough for big data processing. What do you think about this statement? True, false, or any other comments that you would like?
Personally, I'd probably say not, because the needs demanded by big data processing are evolving in an exponential rate. So we'll have to come up with more newer and more innovative tools to assist this process in the statement.
Okay. All right. Thanks, Chase. Anyone else have a different opinion or agree with Chase? What do you guys think, Geeta, James?
I mean, I agree with Chase.
I would agree with, oh, sorry, go ahead.
Go ahead, no, it's okay.
I was just gonna say I agree with Chase. Nothing else really. Yeah, he really took the words out of my mouth. But yeah, I agree with Chase.
Okay. How about you, Geeta?
No, I'm in the same boat as them. I'm just reminded of in one of the discussion posts, one of our classmates had posted that big data is inconsistent and it keeps changing. So I think that is of so much relevance here when you think of how the technology keeps advancing and how changes keep happening.
Yeah. No, and I would say, yeah, I would partially agree personally. I partially agree to this statement and partially not. And I think it is dependent on the use case, right? In today's world, some of our big data processing or the tools or storage management tools that we have in place have become so powerful and they become so robust and they're becoming up with so many different features that based on the use case that you have in hand, the data that you have in hand, maybe it could be good enough. You never know, right? You dump something in Hive and you'll probably just write few queries and you may be okay with that, right? So it may do the job of just analyzing your data set based on what you have. Once again, if the scale is huge, if your data is, as Geeta said, is changing very frequently, and things are changing, so it is so dynamic that maybe even the tool that is in hand is not going to be able to cope up or really work with. So depends on the use case. So that's what's going to be my answer or my take on this statement here. But yeah, I mean, there's absolutely, once again, there's no right or wrong here. What you said was also true. Okay. In today's world, we only worry about real-time data processing. Who cares for batch processing these days? What do you guys think? Guys still thinking?
I mean, I also disagree with this statement. I think we will need older data to help contextualize current and emerging data.
Okay.
So I think batch processing will still have some relevance going into the future.
Okay.
And just to add, like you just said, Professor, I think it really just depends on the use case. So I still think batch processing, it may not be as relevant than it was maybe 10 years ago or 15 years ago, but I still think it's something that we still have to worry about and still learn how to do.
Exactly.
Okay. And guys, you can just call me Lanesh. Don't have to say professor or anything. I would have
Oh,
mentioned
sorry.
introduction. That's okay, guys. That's okay. Let's yeah, we are all friends here, so no worries. That's okay. But I'm just saying. But no, thank you, James. So okay. Geeta, do you have a different take on this, or do you want to agree with both what James and Chase mentioned?
Yeah, I do agree with them. Because batch processing is a term that I've heard at work when it comes to payments that they still practice. So again, it's strictly on use case.
Yes, I too would say that it is depending, but I think it is still very relevant, very powerful, still in use, and very interesting when Chase said batch processing old data. Batch processing, it depends on what you consider as old, right? Batch processing, the old could be just the data from today. As Geeta just mentioned, one of the things that the payments get processed on a daily basis. Banks process a lot of the stuff on a daily basis. Many of these institutions do their processing on a daily basis, or little more frequent than daily basis. But it's huge because you can make use of the computing power in off hours most of the times, right? Or off peak hours. Like, let's put it this way: off peak hours, you're not keeping your computing systems idle, but really making use of them while you could be rejuvenating yourself and kind of coming back in. You're taking, it's night and everybody's gone off from work, and how would you really make use of the computing power? It's that simple. As as a matter of fact, it has led to automation of certain things, right? Okay, when I go home, I just start with this process, I kick this off, the next day I come in, voila, everything's done, or whatever I need to get done is done. or something should occur at 1 o'clock at night, it still happens. So batch processing, once again, doesn't have to be nightly, right? I'm not saying that it always is night, but it could be anything. Like I have got data that is worth, and maybe it's coming in, fast and furious. Every minute I get new data, or every second, but I process data every hour. I let the data come in, and then I will take a full batch of everything that has come within the hour and then process it, right? Maybe some my use case could be like that. So batch processing, very relevant, very powerful. It lets you automate your tasks, and it lets you automate the processing of your data. And it lets you, even, as I said, one of the advantages is it lets you also use the computing power and off-peak hours, right? So, all the companies that you can think of, right? Banking or any financial institutions or pharmaceutical company, all different kind. I mean, the list can go on here, but my point is that you will find I'm sorry, not bill process. I was thinking about billing as well. A lot of these, systems, they're all batch processing systems, and they're batch processing for a reason, because they really don't have to be real time, right? Some of these systems, because that's the need. You can't have a real time. You don't. It's not a social media kind of application that needs to kind of process, every second. It's an unnecessary use of computing power. It's an unnecessary use of processing something, or you could process something prematurely. So that's why there's the reason why some of these stay as batch processing systems, but they are really still needed and powerful. Do you guys agree with me on that? I'll take that as yes.
Yeah,
Okay.
yeah, definitely.
All right, going on to the next one. Adding more memory to your system can increase the in-memory computation of the data. What do you guys think?
I'm not entirely too sure, but I'm going to say yes. But also I'm going to phone a friend to Geetha or Chase, and they can back me up or say
That's
incorrect.
smart. That's smart. Put them on the spot. Just kidding. Okay,
Yeah,
Geeta,
yeah,
please put you on the spot.
yeah. I was just gonna generally agree. I mean, technically, yes, it can, but I mean, there's only so much that your RAM is going to do if your processing speeds are not going to be commensurately as powerful enough to keep up with the amount of data you're going to be pushing both the processor and that RAM, as well as obviously more hardware bits like keeping up a power supply that can handle all that as well too. And
Yeah,
cooling,
yeah.
everything.
No, absolutely. Geeta, do you have any other different take on this one? Oh, did we
Um,
lose someone? Okay. Sorry, go ahead.
I'm going to agree, but then if it's anything different, I'm open to learn why as well.
No, okay. Okay, no, this is no, that's good. Okay. So yes, I would want to say on a case by case basis, but I think what Chase mentioned was really I think very important and to the point, and hit the nail on the head, that not that you increase memory to the system, it's going to lead to that in-memory computation, right? And there's only so much that you can do, right? Just because I'm adding more and more data to my machine, or just because I'm going to process more, how much more memory can I put in this machine, right? I mean, there's going to be some limit to this, what I'm going to be adding to my machine, right? And that's and at that point, if once the saturation hits, I'm out. So it's not just about the memory, it's about the architecture, it's about my design of the process that that I'm having, that is going to dictate how I'm really going to use that memory, right? So my architecture is going to be very important. My design of the system is going to be very important. How I'm going to make the efficient use of the memory. And even if I add so much to it, then how am I going to add more? But at some point when I cannot anymore, then how I can really make my system more efficient, right? So or make my architecture real more efficient in a way that it's going to be really better. So once again, yes, it's not always true that adding more memory to your system can increase the in-memory computation of the data. Okay. All right, because it's not about that memory does not, it just, there's a limitation to how much you can keep adding, right? It's going to, you'll have to draw a line at some point, at some place, right? Okay, alrighty. Okay, so big data processing, right? What are different types of processing? We just talked about batch processing, and I know we went through quite a bit in detail, but it's simple as you process data in small batches, and we just talked about processing can occur an off-peak hour, right? No brainer. There's not much you can talk about it. It's fairly self-explanatory what happens in batch processing. And then came stream processing, right? You're processing data in real time. And in this case, the processing may occur at peak or off-peak hours, or maybe both, right? Because you want to take an action on every piece of data that comes along at any point in time, right? Maybe there's a logs being read that you want to make sure that the logs can, if you're reading the logs of a machine, that if there's some issue, you want to react to it right away, right? You want to probably, maybe you're using all these talk about the self-driven cars and all that stuff, right? You want to read everything in real time and react to it at the real time, right? All these IoT devices, systems that make use of a lot of, the stream processing is going to be so important, because there's no batch processing, right? It's not going to be that, okay, we'll drive for 5 miles and then we'll see whether the car wants to go left or right, right? You'll have to just process it right at the same time, right? So it may be at peak hours, it may not be at peak hours, right? So you have batch processing, you have stream processing, but in today's world, companies would want to take advantage of both these type of processing, right? It's not that they just want to do batch processing, because there's some advantage to stream processing. There are a lot of things. Companies have evolved, our businesses have evolved, our processes have evolved. The way we did banking 20, 30, 40 years back is so different than today, right? There's almost like a real-time banking. You can deposit your check via your phone, and you can just transfer money, and all that stuff needs to happen. And so it's becoming more real-time, more interactive than ever before. And so are many other companies. So I don't know why I keep picking up financial systems, but other systems that you're working with have also evolved over time, that that companies, organizations may not just want to make use of one type of processing, they want to use both. And there comes the hybrid processing, right? Where you want to have the ability to process data in small batches, or also do it in real time. And process could be controlled as required. There could be certain systems that may use batch processing, certain systems that use real-time processing, or certain systems that say, okay, well, we'll do real time during the daytime and we'll do batch processing at night, whatever, based on your needs, right? Based on the use case, you could have make use of the hybrid processing. Okay, so batch processing, stream processing, there could be particular systems that are around to do that kind of a processing. But for hybrid processing, right, we just cannot want to just go on building tools and and having technologies to support each of these processing, especially if the hybrid processing is going to be about using the two other processes that are already in play, then there has to be a way to kind of embed or have both these come together, right? Batch and stream. And how do we do that, right? So hybrid processing does not led to newer tool or technology, but newer architectures of how you would apply batch and stream. How would you kind of mesh these two different types of processing together? So there are some, three different types of hybrid processing that we're going to talk about. The first one is the Lambda architecture. And some of you may have already heard about this, where it is about packaging both the batch and real-time systems together under one hood, right? So you could say, okay, I'm getting a system that's not just going to do batch, it's going to do both. How cool is that, right? And it will have both these independently that they could be used, right? That's what Lambda architecture provides. And then we'll take an example, we'll go into a little more details than just this slide. I'm just going to lay out different architectures, and then we'll go into right into a bit more details about each of them. Then comes the Kappa architecture. The Kappa architecture is that, instead of having both, or two different channels, right, both batch and real time in your architecture, what Kappa architecture has done is that, okay, you have only one channel to bring in your data, but then after you brought in the data, internally within the technology, you can really do the batch processing or the real-time processing, but you just have one channel to bring in your data, right? So in the Lambda, you have both a batch channel and a stream processing channel. In Kappa architecture, you have only a stream processing channel that is going to have data for both batch processing and real time. And then once it passes through, you make a decision of where this needs to be passed through, right? That's Kappa architecture. And the last one is the Delta architecture, right? Where the Delta architecture is really not kind of saying, okay, this is what Lambda does, this is what Kappa does, and I would just kind of try to, again, do a hybrid of hybrid. It's actually, this one is taking it's actually it's gaining some efficiency by making use of something called as delta lakes, right, or incremental data, and also the Spark processing system, and we'll see and talk about that. But this is a pretty cool architecture, right? It is using some very, very high-end technologies, and the type of data lake that is using is becoming, it's become very, not becoming, it's already become very powerful and popular, and so are the other architectures as well. Okay, so what's a Lambda architecture? And I kind of mentioned that in the previous slide, right? Lambda architecture, you have two channels. The one is your batch processing channel right on the top. Once again, this is a very simplified view, guys, okay? Simplified view of the architecture, because this is what you really want to remember about Lambda architecture. I know if you read multiple architect articles, and you'll see much complex pictures of Lambda architecture, or screenshots of Lambda architecture, and it can get confusing. But it is actually as simple as this. And you don't have to take any notes or take a screenshot, because it's going to come into it. This deck will be shared with you. Plus, I have also shared the resources, right? So any images or anything that I talk about, I will always leave a link for you, or a source, so that you can go and dig into a little more details. Because within the hour, we are not going to be able to do justice to, and we're talking about all these three beautiful architectures, right? And that are technical architectures that are really, you can dig in deeper into. And each of them has got, as I said, they've gained a lot of popularity. There are many companies, and you'll see in the future slides, who are making use of these architectures. So when you see the link for any of these architectures, go please spend some time, dig into a little more details, okay? So going back to the Lambda architecture. So Lambda architecture has this two different channels. The batch channel goes to the batch, the batch data goes to the batch channel. The real-time data goes to the real-time processing channel. Now there's one data, though, irrespective of which channel it would go to, it will have a source of truth or a record master data that will be kept in the database, so that any data that flows through is going to be captured and stored, right? And once that is done, there's a layer, there's a serving layer, right? And that could be, once again, in different different technologies, there could be only one serving layer that will house both the batch views and the real-time views, which is going to give you a view of the data accordingly. Or it could have a separate layers, like a batch serving layer and a real-time serving layer. But once again, you can query these data and find out. You can use this data in many ways. The real-time data, once again, you build real-time views, batch processing data, you can batch views, and then you can query this data, right, and save it, right? It's always saved. So once again, based on your use case, you could have the data flow through either of these channels, and you can gain efficiency and plus make use of both these different types of processing, right? Okay. So now if you have to just simply think about building Lambda architecture in AWS, it is going to be very similar to what you see in this diagram here, or this AWS picture here, where you see in the topmost in the batch layer, as you can see here, this is in the batch layer. On the top is the S3 bucket. There's a glue, you get the raw data, you ingest the data through, from the internet. You have a Kinesis fire hose, which is a stream processing hose, but it is sending data to either the batch layer, if there's a batch data, which gets stored in an S3 bucket, and the S3 bucket, you make use of the AWS glue. I hope things are coming back, what you did in the assignment, right? You run a crawler, you save your data in glue, and through that, you have the data, the process, or the data that you see, you can get it through Athena, and you can gain some insights through Athena, right? Isn't this something that you already did? You already worked on a data, and there's almost like a batch layer. You almost worked on the top part there, right? You got the data into S3, you ran a crawler on the top of that data, you got what do you call the schema for your data. And once you had got that, you ran it through Athena and ran all your queries on that data, right? That's what you did. So you almost did that top part. And in the next assignment, you're going to build the second part, right? So having done that, if you can bring these two things together as part of your architecture, you would have built a Lambda architecture, right? So you're going to do assignment 3 based on, or you did assignment 2 here based on this Athena and all that. Now you're going to add some more processing. Yes, you're using EMR, and then also in 4th, then you're building a stream processing layer. You combine all this, you're actually building a very powerful Lambda architecture, right, in AWS. So simply put, in general, what the companies have done for the batch processing layer, they have used technologies like HDFS. HDFS is purely batch processing, right? It's not real time, as you guys know and have learned that earlier. So that's what HDFS is the batch processing layer. You have the Spark as the streaming layer that you'd use for the real-time processing. And Kafka is one of the technologies that is very popular technology that brings in data, pulls in data, all sorts of data can be pulled in, processed through Kafka, And then through Kafka, it gets sent to both these two different layers. And these two different layers can go into one or more serving layers, right? One or two different serving layers. In this case, it is going to a single serving layer where you use technologies like Cassandra, you use technologies like Hive, you query the data through them, and or derive some great insights through them, or build dashboards. We use visualization techniques or charts, or derive or build those charts through these technologies, and you create dashboard. So that's how you would in general use the Lambda architecture. Okay, any questions thus far? Okay, I'll go through one more slide, and if you have any questions, you can please bring it to my attention. So Lambda architecture. So as I said, companies make use of this architecture. Lambda is once again, just because you have two other architectures that are gaining more popularity or are very popular, doesn't mean Lambda is an old architecture. Well, they are being really put to use today. Companies like Yahoo, Netflix, LinkedIn are all making use of the Lambda architecture. Yahoo uses Apache Storm for its real-time processing, Hadoop for its batch processing, and Apache Druid is a technology very similar to Kafka, which is it's a very enhanced data storage or data kind of a layer that pulling in data and then serving it to these two different layers, right? The real-time processing as a batch processing layers. So it's a very enhanced, very robust kind of a technology that could be used. And instead of and having Kafka in front, you could have a Druid in front, or use Druid to store all your master data in. And then that's what Yahoo does. Netflix has a very similar architecture, like a Lambda architecture, which they use. And LinkedIn uses something called Apache Calcite to build to make use of the Lambda architecture. So this is what some of the very popular companies that make processes lots and lots of data is making use of this architecture. Okay, any questions? Okay, so the pros, of course, what are the pros and cons, right? Like any architecture, there's always going to be some advantages, some disadvantages, or some pros and cons, right? In this case, yes, there's a flexibility of the system to use batch versus real time, right? Depending on your use case, depending on the type of data you have, you could either run it through the batch layer or you can run it through the real-time layer. That's a flexibility, right? That's a big plus here. System can evolve very quickly, right? Like based on the use case, you have two different layers. It can evolve very quickly here in this case. Scalability is not an issue, but it requires proactive management. Scalability means you're putting in more data goes through it, right? There's more frequency of data, like you have a real time. How are you going to manage between these two, right? What data should go through a real-time layer versus what data should keep going through your batch layer, right? How are you going to manage it with increased load of data or with increased frequency? How are you going to manage that scalability, right? It's not an issue, but it needs to be thought about at all times. You have to be proactively thinking about it. Otherwise, you're going to really break this architecture or not make use of this architecture very effectively, right? The cons is that the maintenance of two layers, right? Sometimes you're using this system for a single type or for a same type of data, which goes through it, right? I'm getting all these different bank transactions. I'm using bank again. I wish I could come up with a different example. Let me try to get a different example, right? Even in the billing systems or even a non-financial system, if you're getting some kind of a machine data, right? You want to read through it and all the things, all the alerts that you're going, you want to read through it real time, right? And the other, after a certain time, like you want like a batch of like maybe an hourly worth of data that should be processed. And maybe through batch data, you're going to build your machine learning models based on this batch data. It could be similar data that's going through, but then if that's being the case, maybe you're running scripts, or you're doing something on the top of data. You're running some processes or some procedures on this data. And you're doing it both on the batch layer, you're doing it at the real-time layer. And if something needs to change, you will have to change it in both the places, right? So you're maintaining two layers, not one. It's like having a copies here, and anything that you would have put on the top of each layer, you have to make sure it's available on the other layer. If that same changes have been made, or same thing is available on the other layer as well. That can become difficult or complex over time. It still does not overcome the limitations due to CAP. Remember CAP? You could have only two of the three, right? You'll have consistency, availability, and partition tolerance, right? You could have only two of the three at a single time for any distributed system. So it's still not overcoming that limitation. It's not saying, okay, now all of a sudden it has become ACID, or you can use it has become, you have overcome those limitations. You could have all three of them at the same time. No, it really doesn't do that. It gives you different kind of flexibility, as we just talked about. It gives you different kind of a processing power that you can do with your data, right? For both batch processing and real-time processing. Okay. So now I think, yes, I'm done talking about Lambda architecture. So let me open and ask one more time. Any questions on the Lambda architecture? Does this kind of make sense?
Yeah, so far it does.
Okay, good. Alrighty. So moving along to Kappa architecture, right? As I mentioned earlier, Kappa architecture, similar concept, right? You have a batch processing layer, which is, as you can see it in green on the right, is a batch processing layer. What you see in that yellow or orange is that real-time or stream processing layer. Now, both these layers, instead of having two different channels of bringing in the data, you're bringing in, excuse me, you're bringing in through only one single layer, and that's the real-time layer, right? So, excuse me. So, so there's this is in short a Kappa architecture. Well, yeah, you will want to ensure that everything that flows through real-time layer, and if certain things that needs to go to real-time layer, I'm sorry, everything that goes through this channel, real-time channel, is what needs to go to real-time will go to real-time layer, and what needs to go to the batched, I'm sorry, what needs to go to the batch layer will go to the batch layer. But all the data that passes through will be stored in a single master source of truth, right? So there will be one source here that is going to hold, one database that is going to hold all data, irrespective whether it has gone through as real time or it has captured as a batch application in the batch layer. So that is all hold together, right? And how cool is that? As a matter of fact, even the real time and the batch layer will have their own sets of little databases that they can store some portion of the real-time data there, and the batch also can store some portion of the batch data. Maybe you can say 1 day's worth of data would be stored in a real-time storage, right? So any view that you want on the data that is really frequent in the last 1 day could come from here. All the data that is for last 30 days is going to be stored in your batch layer. So if you want to run queries, it will run queries on this batch layer that has got only 30 days worth of data. Anything more, yes, that data that you've been ingesting maybe for the entire month, entire year, maybe that is stored in that other master source of truth, right? Everything is in there. So based on the design of the system, based on your needs, based on your use case, you'll have to design what goes into that little storage in the batch and the real-time layer, and how much, even for this major main storage would also have its own expiry date, right? There will be time where you'll have to take some data off from here and archive it, right? It cannot stay forever, but yeah, it could be much longer. Let's say maybe I want to store everything for 18 months or for a year in a main master source of truth, because I would probably need any data for maybe a year, maybe 18 months. After that, it can go to cold storage, right? So that's what could be done here. But Kappa architecture, yes, and if you want to do or build something in AWS, it is as simple as you have Amazon Kinesis, which can bring in your streaming data or your batch data. It can pull that data in. You could have an EMR, which you're going to do in assignment 3. You're going to use a processing in a service like Amazon EMR or the Spark, and it can do that. And once it has passed through, like you brought in any kind of data, you pass through any kind of processing, you can save it in one of these databases as a batch layer, and or as a layer that is going to be much more faster than a batch, which is going to be a real-time layer, right? So based on that, you could either make a choice to put all your data in S3 or your RDS or your DynamoDB or Redshift, right? Depending on, once again, your use case. And you can use these layers or databases accordingly from where you can query these databases, okay? So some of the companies that make use of Kappa architecture, like Kafka, Uber uses Kafka-based real-time infrastructure. Shopify uses Kafka, Flink, and data syncs for a try-blocks-based approach. Disney uses a Kafka cluster approach for single source of truth. They bring in all their data and store it in a single Kafka cluster. Okay, Kafka cluster means multiple. Of course, there's multiple of them. When I say single, doesn't mean a single machine, but a huge cluster. They store all the data, and any department that needs this data, they just would give it to them from this single cluster. So that's how powerful. So everything that Disney brings in, remember, all sorts of data that Disney brings in, it stores it in this single Kafka cluster, and which becomes a single source of truth that is made available to all different departments or the organizations within Disney. Okay, then there is Twitter, right? The Twitter, which uses GCP cloud with Kafka. And so once again, Kafka is, as you can see here, Kafka is used by each of these companies to ingest data, to bring in data, and to process the initial data that is brought in, or for simple storage or temporary storage, and then serving it to the different layers within this architecture. Okay. So some of the pros and cons of this Kappa architecture. So the pros is a single data processing engine. So as you can see, there's a single channel, right? So the maintenance has been reduced by this architecture, right? So this is because there's only one single, as I said, the source here to bring in the data. The system can evolve very quickly, very similar to the other architecture, right? The previous architecture the Lambda architecture, the system can also evolve very quickly. The scalability may become an issue only over time, right? Once again, very similar. If you have been maintaining, if you know what amount of data would be brought in through this single real-time processing or stream processing channel, scalability will not be an issue. But if there's not much thought given to how much data that you could be bringing in through this channel, or how much data would be stored or going to these different layers, then that could become an issue over time, right? So some thought need to be given on how your system is going to scale. But for the most part, if everything remains same, or the status quo is maintained, it should not be an issue at all, right? Your system should work flawlessly. Some of the cons here, of course, there's increased demand of computational power. Why do you think I say that, right? Why do you think there's an increased demand of computational power? Anyone? Does anyone want to take a stab at it? Why do you think the Kappa architecture, one of its limitations could be an increased demand of computational power?
I guess one potential aspect, since it's all hosted by AWS, there's only so much that they can requisition to a given contract or a given client, since they're having to share all their processing power with other clients. So they're the one, like, really the burden's on them to keep up with the scalability of their architecture.
Okay. Anyone else? Any different take on this? Okay. All right. So as we are saying, right, we have a single channel here, which is a real-time channel. So irrespective of any data that is coming in, you are treating it as a real-time data, right? Whether it's a batch data or that data that you don't need to act on it right away, or process it, right? It is a real-time channel for you. So what you could avoid doing, it is doing it, and that's why your computation power has increased. Your demand for the computational power increases because you are treating, irrespective of what type of data it is, you're treating it as a real-time data, right? So you are making your system work, maybe unnecessarily at times, because you could be just consuming only batch data, yet you're using a powerful, a real-time channel to kind of pull in that, bring in the data. Okay. There's increased demand of storage capacity too, right? You're bringing in, yeah, there could be at times when you're bringing in, because of the fact that everything is processed through real-time channel, you could have more storage capacity over time that may be needed. So yeah, so that's another limitation of the Kappa architecture. And Chase, just to mention, Kappa architecture or the Lambda architecture is not specifically for AWS only. I was just showing you how it could be drawn or built in AWS, but these architectures are general architectures, which our companies are using, maybe other cloud providers or maybe their homebrew kind of systems, but they could be just doing everything on-prem and not going to AWS or to GCP or anywhere. It could be just everything could be on-prem, and they could still be using this architecture here. So this is a pretty general architecture. Okay. All right. So which architecture should you choose, right? Once again, when you have too much of choice, which one do you use? Would you say that, oh, Kappa is better because, hey, it can evolve very quickly, its maintenance is low probably, and it's not much complex, so Kappa is the winner, and Lambda is not because it's always about batch data? No, not really not. Each has its own distinct advantages, which makes them still stand out and being used. So these architecture did not just evolve because, hey, Lambda is not doing this, let me do this and let me get better and I'll just knock out Lambda out of the market completely. Not really, right? Both these architectures are still relevant. They still could be used and are used. Also, as you saw, there are many companies that are still having these architectures and using them as well. So there's no clear-cut winner. The winner is the use case, right? Based on the use case, you will say, well, I really don't need Kappa at all. I'm never, or maybe I need just Kappa and I don't need a Lambda at all, because all I'm doing is mostly my 90% of the work is real-time processing. And so I'll just use Kappa, right? I still need 10% of batch processing, but because Kappa is also going to support batch processing, I'll go with Kappa. Lambda, you could say, well, I've got both equally, or maybe 60-40, 60 batch and 40 real time. But I need to have both these channels. Then, well, there's Lambda, right? And maybe there's not much of what changes that, or maybe you'll be doing a lot of processing or having scripts on the top of the data that you'll be serving or having in these two layers. So maybe there's no question of more maintenance or complexity that will be added on. So maybe you'll choose Lambda, right? So once again, the winner is the use case in this, and that really dictates which architecture you would be using. The third and the last architecture that we will be talking about, oops, I just saw that I'm kind of running out of time. I know this is for an hour, but could you guys hang on for 15 more minutes? Would that be okay, guys? Does anyone have a hard stop at this time? I just checked the hour and I realized I probably have shot up and gone up by a minute already. But I still need a few minutes to go over this architecture and then a few minutes to go over your assignment very quickly. 15 minutes be okay? I see Geeta saying, sure thing.
Yeah, that should be
Okay.
fine. Not too
Okay,
much over.
thank you.
Yeah, it's fine with me.
Okay. So Delta architecture did not just came up to say, okay, well, Lambda is doing this, Kappa is doing this, let me do it differently. It's actually gaining efficiency by using a data lake and a Spark streaming. And it is using a data lake which is actually called the Delta Lake. Data lakes by nature are immutable, right? What that means is if you design something within data lake, right? If you have a structure in data lake to store your data, if any point in time you have to change that structure, or you may be saying, okay, I changed this structure, done, right? You may probably just send up a command and it will do it. But what it is doing internally, it's actually pulling all that, making probably a copy of all the data that you have, taking the structure away, putting up a new structure, getting the data back in, because it is actually building a new version or a new structure for you inside. It is not updating the existing structure. It is immutable. That's why data lakes are immutable. There's also an issue with the read and writes there. The data lake, the way they are designed or by nature, if you are, you could be reading something that is still being written, and that may not be right? Unless it is programmed to read only when everything is written by nature, by default, you could be able to read that. So these things, Delta Lake came up to become more efficient in that way and better off than the basic or the original data lakes. And it also went by not just gain efficiency from what I just mentioned, but also in the fact that here Delta Lake would be able to also help you with the incremental data to kind of have a way to kind of say, okay, I'm going to have a space or some way I would know what my incremental data is, and I'm going to work on my incremental data that is going to come in maybe the last few minutes, few hours, few days. That would be my incremental data. The rest is going to be going into cold storage or other types of storage. So Delta Lake gains efficiency by storing or working or processing on data that is really, really needful, right? On the top of that, the processor is the Spark, Apache Spark processor, streaming processor. And that makes it a very, very potent, a very strong combination and an architecture here. So that's why you will see this one again becoming a very, very powerful architecture that is and a popular one that is now being used by multiple companies here. So as you can see here, the Delta architecture, and I know there's a lot on this slide, but if you just look, if you look at it for a few seconds, you'd notice that again, here too, there are two different layers, right? You will see there's one layer that is having a data lake, and with it's everything, all the batch processing, all the batch kind of a data is coming into the data lake. The real time is also coming through the real time channel, but also it is being, it all after it processes the real time data, it takes it into the data lake, right? And it everything is brought into the data lake, and you see that there's a cube there. The cube is nothing but it is having that incremental data that I'm talking about, that last few minutes, few hours, few days of worth of data that you will be constantly, work or querying or trying to figure or monitor or retrieve any kind of data, or make sure that this is available to the serving layer at the fastest speed and at all times. That will be stored in this cube. And anything that you stored in the data lake, right? In the data lake is huge. Once again, that's a basic data lake, which has got all the data. It's the source of truth. Is also can be used to, do any kind of machine learning, right? You could be using that for machine learning, building your machine learning models, right? Your incremental data, once again, it's stored after some period of time. You could say, okay, rebuild my model every 10 days, every month, right? Or at the end of every day. But your data that is in you are bringing in every second, maybe there's some kind of real-time analytics that you want to do. So you can also do real-time analytics on the real-time data that you are ingesting here, right? That you're bringing in. So it brings in, and it uses both this channel technique here, but it uses also the powerful use of a data lake or a delta lake, because you now have that incremental data that you could be used or could be saved little separately from all the data that you have, which makes it again powerful for queries, right? And you can have on the left, you could have all different types of data that you can bring in, right from files or to other databases, to Twitter, to social media kind of applications. You could bring in all that data. On the right, you can see the different serving layer that it will have, right? It can serve to, and the serving layer could be like building queries or bringing API calls to this data, and you're kind of serving that data to this app, to the applications. So there are multiple deployments of Delta architecture. There's Capital One in banking, United Health Corp, health insurance, Costco, wholesale, retail, GlaxoSmithKline, pharmaceutical, Ignify, also one of the software manufacturers. And the list can go on, guys. I mean, this is not just the only companies that are using it. I just picked up a few examples to just put it up on the slide here. But there are many more that you would see that are part of that are having Delta, that are using Delta architecture. And it is gaining a lot of popularity. As a matter of fact, it's already popular. Let me not say again gaining popularity. It has already gained a lot of popularity, and a lot of companies are already using that. And in terms of big data processing platforms, you can see that in AWS, you have an EMR that you're going to work with in assignment 3. In GCP, you have something called Dataproc. In Azure, you have a service called HD Insight. In IBM, and these are all the cloud providers, by the way. I'm just listing all the cloud providers here that you could use, or you could simply go to any of this cloud environment and make use of these services that are very powerful big data processing services. So before I go any further, I just wanted to, before I go on to the next topic, I also wanted to put in a link here for a top 10 big data frameworks for 2022. So you want to take a look at, it's just a 5-minute video. It was actually 7 to 8 minutes long. I just cut it short for you for 5 minutes, and I'm leaving this link here for you to kind of quickly go over that and then see what are all the different, or your top 10 big data frameworks that are still very relevant, and especially as it was back not too long ago. It's in 2022. Okay, so before we go on, some food for thought. some questions for you to think about after this session or after this module. How would you take your learning about big data processing forward? What is your plan to practice the knowledge and skills you have learned during this week? Have you researched areas to find big data sets, AWS databases, and processing technologies for practicing your skills? Okay, some questions for you to ponder upon and get answers to. Make sure you work on these answers, right? And then all these things that I just mentioned. Okay, so moving along very quickly on assignment. Oh, before I go on, any questions on these architectures? Anyone? You guys good with that? All the three architectures that we talked about? Okay. So assignment 3, we are going to be using AWS EMR, Glue, and PySpark to explore and analyze home credit data. So it's the same files, same data, but in this case, we'll just use one of those files. You will make use of AWS EMR, the big data processing or service that is available in AWS. Very powerful. And you're going to use the power of PySpark, right? The Spark engine in the background and using the power of Python, right? The PySpark. So you'll use PySpark for that. Most importantly, you will have a quiz. Without completing the quiz, the assignment is not going to be counted as complete. So please, you have to do both. You have to complete the assignment. You have to complete the quiz, and you have to submit the assignment document and with your answers and screenshots to receive full credit for the assignment. Okay, keep that in mind. The purpose is to make use of the Spark framework in AWS, Elastic EMR, Elastic MapReduce, and also use the power of PySpark code to explore the same data set that was used in assignment 2, right? So you load the data in AWS S3, and then you would use also one of the most popular big data storage solutions, such as Data Lake, which is S3, and then make use of AWS services such as Glue to apply structure to the data loaded in a data lake, and then explore and visualize this data using the PySpark code in a Jupyter notebook, okay? Which will be running on the Spark platform. Okay, so the goal is to explore and go over the data, which is going to be mostly the application data, and we won't go much further than that. So just the application data. And you'll explore and conduct analysis using the PySpark notebook. So just a picture here, you're putting in bringing the data, putting it in AWS S3, which is acting as a data lake for you, and you process through EMR. And of course, before that, you process it through group, use the crawler to and have your database built and put in the Glue catalog, and then you're going to build an EMR, the processing engine, and using a PySpark code, you're going to pull the data in and analyze it. Okay, so that's what you're going to be doing in this assignment. You know about the prerequisites. I'm not going to go over through that. You can read through that. Special instructions is mostly to just make sure that you record the screenshots correctly, record your answers. Cleanup is going to be another important thing, and make sure you also complete your quiz. As far as do's and don'ts, cleaning up is a huge thing. Please clean up all AWS services after your lab is done. And remember, lab can only be continuously available for 4 hours, after which you'll have to exit out, restart, and go back in. Okay, all right, this is just the rubric that you'll also see within the assignment. So yep, there's lots of points that are based on this assignment. So you don't want to lose your 100 points for this assignment. Okay, this is, if you do everything step by step, everything goes perfectly, there you get your 100 points, right? It's as easy as that. It's either you don't get it or you get 100 points. As simple as that. You can't go wrong. All right, so let me open up for questions, and sorry I went over 15 minutes. But I thank you for being around and hope this was helpful, Kyle. Hope this was the good use of your time today. But I'll open up for any other questions that you may have. Chase, Geeta, James, any questions, guys?
No, no questions on my end.
No
Yeah, I'll
questions
be
on
in
my
touch
end,
with everything
Lanesh.
that I-
Thank you so much.
Okay, let me stop the recording then.